Look at your wrist, and you are likely to find a wearable smart electronic device such as a Fitbit or Apple Watch. Smart electronic devices like these have had a massive impact on our health by letting us track how much standing we do in a day to helping us set daily exercise goals. The newer models are even able to track our blood oxygen content and our heartbeat. By tracking our health more efficiently and more effectively, we can detect issues sooner and more accurately, with early detection being a key to treating so many illnesses. However, these electronic devices are currently being made with precious metals such as silver or gold, which need to be mined from the ground and are not in great supply. Metals have the added challenge that they form very rigid materials, limiting how flexible we can make our wearable electronics. Look to your watch again and you will see it is time for a change. We need to look for alternatives that are made using more environmentally friendly materials. Carbon can be found everywhere. It's in the trees and the plants, making it one of the most abundant elements on the planet. Carbon chemistry offers a lot of choice to me, a chemist, to change my materials to get more desirable behaviors. Carbon also doesn't form such stiff bonds, and therefore can be made into more flexible wearable material. My research looks at designing materials that are made up of mostly carbon that can be used for electronic films. I start by dissolving my material in water, which is an abundant and environmentally friendly liquid to work with. The liquid is then poured onto a surface to dry into films, and these films can be later incorporated into electronic devices. The conductivity of my materials can be changed either by changing the pH of the water it's dissolved in or the chemical structure. You can think about my materials in water like beads that have been thrown onto a table. Individually, they're quite small and they scatter into a huge mess. But when I lower the pH from 7 to 3, the beads string together and you get a stylish bracelet. By stringing them together, they stack more uniformly, which improves their conductivity. Alternatively, with a little carbon chemistry, I can change what my beads look like from red to blue. This will lead to a change in both how they stack together and how conductive they are. I can then pour my dissolved materials onto a surface and let them dry to get lovely electronic films like the ones you see on my slide, giving me an array of different beads to use for my design of the next big thing in wearable electronic fashion. Thank you.